All right, so this is on page 112, and what you're going to do is you're solving log and exponential functions. So there's several parts that are going to, or techniques that are going to happen in here. Remember, the goal is to get the variable by itself. So once your variable is by itself, then you have solved. So if your variable is in the exponent position, what that means is you are given an exponential function, you have to solve it by using logarithms, okay? So in this case, you notice there's no e, but with natural log and regular logarithmic functions, or common logs, those are both functions, so they're operations. So as long as you do the same thing to both sides of the equal sign, then you can actually solve. So first things first, this is number 15 on page 112. First things first is you want to isolate. Okay, so within the parentheses, we can go ahead and put that together. So I have 250 equals 500 times 1 point, oops, sorry, we're not adding, we're subtracting. 1 minus 0.07 is 0.93 raised to the t power. Okay, so go ahead and get the calculation within the parentheses first. Now I'm going to divide off the 500. And the reason why I do that is I want to isolate that exponential function. Okay? So 250 divided by 500 is 1/2. That canceled, so I have 0.93 raised to the t power. Exponent is the variable is in the exponent position. I want to get that to drop down. So if you recall, when you had the power rule with logs, you would bring the exponent to the front and multiply. These are not logs yet. So what I'm going to do is I'm going to ln both sides. Now, you can also log both sides. It doesn't matter as long as you are consistent. I just go to ln because it's the one I'm most comfortable with. But over here, if I do log both sides, you can see that we're going to get the exact same answer. So I'm going to do it both ways. Okay, got to get my calculator. Hang on. I have too many different places that I'm teaching from. Okay, so once I log both sides, now this is an exponent, and I have an exponent on an exponent. So let me get rid of this one. We'll do this one later. So now I'm going to bring the t to the front. It now has just dropped down. T times the ln of 0.93. Okay? And then to get t by itself, I'm going to divide by ln 0.93. So once t is by itself, now you can use your calculator. Do ln 1 divided by 2. Make sure you close the parentheses. Divided by ln of 0.93. And we get 9.55 equals t. Okay? So work inside the parentheses. Isolate your exponential function by dividing off. Then you reduce it. Then you take ln of both sides, which drops that t to the front. So then you can divide off the ln 0.93. Now, if you do this by logging both sides, you're going to do the same thing. Because I logged both sides, this makes the t drop to the front. Oops. Equals log of 1/2. So then you can do log of 1 divided by 2 equals divided by log of 0.93. And you still get, so we're dividing both sides by 0.93, log 0.93, and you get t equals 9.55. So it really does not matter whether you log or ln, just be consistent. Do whatever you do to both sides of the equal sign, and your function will solve. Okay, so let's try number 16. So number 16 is 100 equals 500 times 1 minus 0.07 over 12, all raised to the 12t. Okay, so this is actually an example of a compound interest problem, which we are going to get into, I believe, the next function or the next section. All right, so we're going to isolate, I'm going to get the inside the parentheses. So with this one, so inside the parentheses you have division here, and then 1 minus this value. So go ahead and do the division first. So 0.07 divided by 12, and it's 0.00583. And then you're going to go 1 minus that. So inside parentheses, I get 0.994166667. Make sure that you do not round too soon. Keep as many numbers as you can, okay? So now I want to isolate. So I'm going to divide both sides by 500. I get 1/5 equals 0.994166667 raised to the 12t. The exponent has a variable. I want to drop that down. So I'm going to ln or log, doesn't matter, ln both sides, which drops this to the front. 12t times ln 0.994166667. Okay, again, I want t by itself. So I do this in 2 steps. I divide off my ln first, and I get this answer. That cancels. So I do ln 1 divided by 5 equals divided by ln 0.994166667, and I get 275.0982962 equals 12t, and then I divide by 12, because again, I want the t by itself. So I get t equals 22.925. or 22.9, depending on, I don't think it tells you 3 decimal places. So we want to go 3 decimal places. So there it is, 22.925. Okay? Now, number 17, there was actually a misprint in the problem. So let me show you which one this is. So this is number 17. So please change this in your packet. Is 1,000 equals 500 times 1 plus 0.01, and in your packet, there's a t in there, all raised to the t power. This t should not be there, okay? It won't work. So, same thing as what we did before. We're going to add inside the parentheses first, raised to the t power. I want to isolate my exponential function by dividing off the 500. 1,000 divided by 500 is 2, equals 1.01 raised to the t power. Don't like the t in the exponent, so I'm going to ln both sides. What that does is it brings that t to the front. So I have ln of 2 equals t times ln 1.01. I want to isolate my t, so I'm going to divide by ln 1.01. Okay, then you come to your calculator, do ln of 2, close it, divided by ln of 1.01, and close it, and you get t equals 69.66, or 69.7. Okay? All right, so that is when you have an exponential function and your variable is in the exponent. All right, now we're going to switch to when you have a log function and your variable is just within the log. So we have, this is number 18. We have log base 2 of 4x minus 1 equals -3. Okay, so this is just like what we were doing before when we were solving given a log. So remember, when you're given an exponential function, you log to get rid of it because they undo each other. when you're given a log function, you're going to rewrite it as an exponential function. So this is log base 2 of 4x minus 1 equals negative 3. This is my base. This is my exponent. This is my total. Okay, so base, exponent, total. All right, now I just solve it. 2 raised to the negative third is the same as 1 over 2 cubed, which is the same as 1 over 8. Now I have a two-step equation. I'm going to add 1 to both sides. I'm going to finish it over here. So I have this 1 can be written as 8/8. So I have 9/8 equals 4x. Divide both sides by 4, which is the same as flipping it and multiplying. So my answer is 9 over 32. If you have a decimal answer, it is x equals 0.28125. So remember, when you change a fraction to a decimal, you type it in the same way it's written, 9 divided by 32. Okay? So that's number 18. Number 19 is log base 3 of 2x plus 1 equals 4. 3 is my base. 4 is my exponent. The total is 2x plus 1. So 3 to the third power, 3 to the fourth power is 81 equals 2x plus 1. Two-step equation. I'm going to subtract 1, and I get 80 equals 2x. Divide by 2, and I get x equals 40. Okay, now again, you can always plug your answer back in and make sure it makes sense. 2 times 40 is 80. 80 plus 1, so you have the log base 3 of 81 equals 4. Is that a true statement? Well, 3 to the fourth power does equal 81. Okay, so make sure that you feel comfortable going back and forth between a log and an exponent and a log. All right, last one, number 20. This one is 5 times the log base 4 of 5 minus 2x equals negative 10. So again, we can't do anything until this log is isolated, right? We have to have an isolated log in order to do anything. So I'm going to divide by 5, get rid of that 5. So I have log base 4 of 5 minus 2x equals negative 10 divided by 5 is a negative 2. Now it's isolated, so 4 is my base, negative 2 is my exponent, 5 minus 2x is my total. So 4 raised to the negative 2 is 1 over 4 squared, which is 1 over 16. Okay, and now I can solve. So I'm going to subtract 5. So remember, just a real easy way to change fractions. I have 5 times 16, because I know that my denominator has to be 16. So negative 5 is the same as 80, negative 80 over 16. So I'm going to rewrite this over here. So I have negative 80 plus 1, so I have negative 79 over 16 equals negative 2x. Divide both sides by negative 2, which is the same as multiplying by negative 1/2. You just flip it over. And I get negative 79 over negative 32, which is 79 divided by 32, which is 2.46875. That's what x equals. Okay? All right, that's number 20. That's how you solve exponential and logarithmic functions.